So now you should hear me okay. So yeah, so I guess now you can see me well, right? Please let me know plus minus. So again, crazy day today. So anyways, I hope you can let me know in the chat. Maybe it's too loud a little bit. Let me see. Hopefully now it's okay. Okay, so now, yeah, so now please get the template. So I already shared the link for the template in the chat. Also, we'll make sure that you have it in the description below the video. Just a second. Template. And we also we're gonna look at the homeworks, and we were gonna have some new things today as well. Because I wanted to check out last time when we had this workshop, I was thinking about is there something similar to numpy in JavaScript, and then I found this library called Numjs. So we will look at that one, and we'll also implement the Singleton design pattern in JavaScript. So that will be good. Just a second, we'll share the Jamboard as well. So please get the template meanwhile. So get the template meanwhile. And this is the Jamboard. And I will also share the Google Chrome, where I will have the running code, basically, of what we have to do today. So today's template looks empty at first glance because I changed a few things, and I wanted to talk about them in a little bit more detail. But meanwhile, please get the template. Look at it a little bit, and we will also look at the homeworks just in a second. I heard that there were some problems with the homeworks, so we will see what is the situation. In order to make this quicker, I will just use just one file for all of them and examine them one by one. Okay, I see a few versions. So let's start with Everett's version. So let's see how Everett's version is working. So if I drop the code here, and the requirements was to make sure that you can end the game, that you can not shoot too often rockets, one rocket in a second, one rocket each second. Implement ability to shoot down elements and implement explosions as well. Okay, so let's see. And then we will examine. So, okay, let's see. So inspect code. So this is Everett's version. So let's see. So we can move. So that's good. We can move. We can shoot. We can shoot even down the elements. So that's at least that element we could shoot down. And the score also increases, so that's great. Thinking generally, like, can we shoot too often? So we cannot really shoot too often. So I think all of the requirements were implemented, so good job, Everett. So let's see then what is the code in the background. So let's see. So let's zoom in. Oops, zoom in. So this is this part. Okay, one thing about the code. Please, please, please make code a little bit more readable. Right now, everything is just at once like just like written without any spacing and stuff. So please add more spacing so that it would be separated parts of the code. And also maybe the tab. So I mean, like how many spaces you have for the tab. Like for me, myself, for example, I think I have a larger spacing, at least because otherwise it seems very, very short. But anyways, that's not important. Anyway, so here you have So you implemented the firing option using the interval. So my kind of like take against this is probably, so you false. So this is not always in 1 second interval, because of course you can shoot in between those 1 second. So it's possible that you will shoot 2 rockets immediately, one by each other, if this interval fires just below that moment. So instead, you should be, so this is not optimal, but it's at least some kind of solution. Also, there is another problem. If you set any interval, then you also get by default some interval pointer. So here will be the let's say the pointer to interval controller. So, and this one is then like something that you will lose if you will not store it. And also, if you end the game here, it will, in this case, you close the window, so that doesn't matter. But in other ways, it's like it's never good practice to create an intervals or timeouts without getting the pointers. So here in this case, we do create a timeout without a pointer, but here there is a very short period and nothing happens in between that period, but this is a little bit tricky. But anyways, good attempt, but this is not perfect. So let's see what about other things. So what about the collisions? So I don't see collisions here. That is interesting. So where do you have collision? Okay, you have something here. So there's an update of a rocket. So you're checking only collisions between rockets. Maybe that's not too bad idea, but maybe there could be some other types of collisions as well. But rockets are okay. So then this is also extremely long spaghetti script. So please try to avoid this. So first of all, you could create a new lines. So that would be one thing. Another thing, often it's much better to try to write it step by step. So what I mean step by step is something like, if this doesn't equal that, so let me see. So if this does not equal that, then you would check the position next. If then something else happens like that, and step by step. So this is much more debuggable. So if there is a bug here, I can add breakpoints in between those calls, not just like one huge spaghetti. So that could be improved, but of course this is not terrible. This is just one way. So then, yeah. So this is something you should never ever do right now. Please do not do these things with, or maybe I should start adding things to the Jamboard, which I will do now, because you already know the jQuery library. So, and jQuery library is very convenient, and basically it solves all of the issues where you need to change something inside the HTML. So please never use the direct met functions to the browser by getElementID or something like that, because all of those functions are browser specific. There is no like standard. So if you would run some of those functions on the Internet Explorer or the Edge or something like that, there will be differences then from Chrome and Safari. So that's why you should use instead always jQuery. So use jQuery when editing. So I will drop this image just in a second. When editing HTML, so never do this in like using the direct editing. So, and then also avoid spaghetti scripts. Okay, so I will just, that's actually a good idea. Just drop these some comments, which are quite serious comments sometimes, in the Jamboard. I hope that all of this information is useful for others as well, and not only for Everts. So, and dropping this here in the Jamboard. Super slow, I don't know why. Really hope it will drop there. Okay, cool, now we got it. So that's one. Then I will also go back go back here and let's go back to the place where was the runaway pointer. So this is not especially intervals. The intervals can do bad things. They, like if you create an interval without any way to stop the interval, so that's a very dangerous code. So never create intervals that cannot be stopped. Plus also the logic is not perfect there, but still. Okay, anyways, the one thing that I must say is that it's good that Everett's managed to get the result done. So that is good, but the way how it's done, it could be improved. So here in the Jamboard, I dropped those few comments. So now I'm going back to the code. So I think other parts seems as it was okay. So that's great. Okay, so I'll look at the Rockets version as well. So where is the Rockets version? So Rockets has 2 versions. We'll try to find the implemented optional part as well. So that's great. That's great. Let's see that part. So this is really helpful. If you do the homeworks, then I understand what I can advise you to do in order to make the code better and sustainable. So now, if I try to run this code again, just a second. So go to the version where I can see it. Inspect. Let's see. There is no bugs. Hopefully, console, right? So I can move. That's good. I can shoot. Yeah, there's also the explosions happening, which we will make today as well, and the score is increasing. So all of the great things are happening. So that is perfect. Okay, great. And I cannot shoot too many rockets at once. So let's see how it's done in Rockets code. So I think so far this is the best code we have. I mean the best result we have seen. Let's see what about the code. So. Fire rocket patience. Oh, so that's good. I like this. So we have some kind of built-in patience. That is good. Okay, and then we have the collision code, the for loops, which are not effective because you are repeating the. So you're repeating the same check twice because. So this is not effective code at all. So if you have the situation where you need to check one element by another element and order is not important, because in this case order is really not important. It doesn't matter in which order you check them. Then this is not optimal algorithm. So this is like wasting a lot of resources. So but anyways, at least it gets the job done. But it's not excellent. So let me show a few other things. Okay, let me actually show the full screen so I can annotate it. So here what we have, so first of all, this is bad. I think it is bad because, yeah, this is definitely bad. So never make global variables in JavaScript like that. So never declare global variables in JavaScript. Well, so this is basically global variable. So the correct way would be to let element1 equals something. So this is the correct way. Correct. To make it scopable variable. Otherwise, this will be alive also outside of the scope, and this will make a huge problems. Then also when possible, always use this kind of syntax for comparing things with 2 equal signs. So basically or something like this, because here both element ID data types match. Last time I showed you that the only reason why you would like to use this kind of sign is following. So if I try to compare, let's say if 1 equals 1 with the string, so this will be true. And basically, if, for example, 2 doesn't equal like something like this, then also that will be true, right? So, but anyways, in this case, like the correct way how to write it would be to not allow to compare 2 different types of data. So there would be always comparison just only between the same data types. So here this will be a true, and if I would try to compare this with this, then this would be false. So I hope this is clear. So the two equal signs or 3 equal signs are quite important in JavaScript. So always use 3 equal signs. Also here the same problem. I really don't know what I did wrong when I was explaining things, that you did not understand how to use jQuery, because jQuery is the most powerful library for HTML editing. So you should never ever use something like that. Use jQuery. Not this. So, and in jQuery this would look something like like if you would try to do this in jQuery, it would be hashtag, because that is the CSS selector, span score, and then you would define what will be inside HTML there, and then in that HTML there will be the in this case Rohit used the C++ type of score adding, where you can return the value from 2 pluses if they are on the left side. So that's fine. Okay, so this would work much better. Yeah, so that's one thing. Okay, is there anything else here? So the remove, explosion, right? The only thing that this is not efficient, so not efficient at all. Because the order is not important. So if you would try to submit this code for some kind of coding competition, you will not get good points for this job, because the way how you write algorithms, you need to think with head also how to do that. So okay, let me see what's up here. So we see that we have some kind of thank you for reporting the spam in the chat. So that's funny. We got some kind of a bot posting stuff in our chat. We'll try to remove the like trash that we got there. That's really funny. Never seen that before. Anyways, so let's keep digging. So okay, what else we have here? So the patience variable, which is good. Okay, that's good. Reset patience, that's nice. We could implement in the same way ourselves as well today. And what about the explosion? Where is the explosion? Explosion, life, right? Delta 0.5. Seems fine. So yeah, great job. So as far as I know, like this was I think the best code so far today. So and let's look at the last one from Christiana. So I hope that she also managed to do something, and if not, still it's a good way to learn. So anyways, so let's see if I'm running this again. So switching to this. Why it's not opening? Oh no, what's happening? Oh, come on. Close this thing. Try to run it again. Okay, anyways, while it's super slow loading, we'll try to look what we have here. Yeah, I don't know what's wrong with it. Really hope that it will not crash or something. Anyways, maybe there is some kind of bug there. I don't know. So let's see. So for loop. Then what we have here, there was an attempt to doing the collisions, So again, I think this was exactly the same problem for Christiana's work last time in Python, and I don't understand exactly how to explain it better, but maybe some of you can help me out. So if I try to look at the whole code at once, like this, so here in this part, so let me actually also make an annotation here. So if you look at the whole code like that, I understand that this is very small letters, but anyways. So here we have the main game loop. So this is the function that is being called every 100 milliseconds. And this part of the code where you try to attempt to create the collision check, which is not wrong, you know, like you try to do something try to do similar that we had in Python, but and also even syntax here. The syntax is very similar to what we had with the Rockets code, right? So this is okay. But the problem, the main big problem is that this part of code will execute only once. So we'll execute only once when we run the script, this part, basically the lower part, because there is no loop there. This is only happening just one time. And the upper part, there is this, this will execute many times as in a loop using set timeout with 100 milliseconds. So basically any part that you created here should actually be inside that those two brackets, basically inside that part where there is the main loop. So it doesn't make at all sense to create some kind of checking of collision outside of something that is so it's not actually updating any time in the game. So it's only updating in very beginning of the game where there is no collisions at all. So there will be no effect of this code. So that's one kind of problem. Also, probably there is some kind of yeah. So there is that's why my code broke, because you are using twice I here. And this why it's just hanging, so it's never ending. So you have so this is like hang up is using I in both loops. This is the reason why I cannot even run this code, because there is twice the same variable there. But in general, it looks similar to what we need, but not really exactly what we need. So I will drop this also to the Jamboard, so you can check out. Let me quickly see what else we have here. So if I'm just removing this wrong part of the code, trying to zoom in. I assume that you already got the templates, right? Yeah. So it didn't open for you, I see in the chat, because again, let me show why. So you have a one for loop, which means I will go from element 0 to element end, right? And if I go to the end, then I can exit this part, right? And then the second one says I will go from j till element end, but j never gets updated because you have I here. There is no j. There should be j here. So if there is no j here, this part, if I leave as you had, like this, then what happens is that this loop here executes forever and never ever exits at all. So that's why you cannot even run it, because it will be stuck there forever. So basically the one way how to avoid these things is you could add breakpoint and then run using basically the debug, this button here, and then it will stop at that part and you can examine what is wrong there. But otherwise we cannot even run this part of the code, unfortunately. So let me then try to do this again. Okay, so that code is breaking. So let's see about this one. So console, okay, so firing. So okay, so there's no other changes, I guess, in the code. So it seems the same as the last time. Okay, good. So at least you know, now you know where there was a problem. Basically, this part of the code, there should be J, and all of this stuff should be written inside the main game loop, not somewhere in a random position. So here, basically. And also, there's a, so this would also not work, basically. Maybe I should also annotate that part. In the Python, actually, we use type of function, and in JavaScript, there is also a type of function, but this will not work like that. This will be totally error. So the way how to check the type, to check type in JavaScript, you should then write the type of thing. So just a second. JavaScript. Just want to see the syntax again. I think it was type of type. Yeah, there is a type of. And then also there will be probably problem because it will not be exactly that type of which we expect it to be. Just a second. Instance of, maybe there is an instance of function. Yeah, so this will be much better. So in JavaScript you should then write it as element is instance of rocket, basically. So this kind of syntax would work the same way as in Python. There was type of and then or type and then equals to rocket. So basically there are differences, and even if something is not working exactly like you should, like you think you can do, remember that, for example, Rocket's code, I think it was, and also Everett's, I think he implemented that. You can use some alternatives. You know, you don't need always to use the types. You can try to use, for example, the character, for example. Like if we go here, you see that we have the inside the mobile element in element. In element we have this variable character, and you could check if this is a correct type just by that character, for example. Like, is this a rocket or is this a wall or something like that? So it's not always that. Anyway, so let's go back to today's code. I realized that we lost quite a lot of time, but it's fine. It's really good that we can discuss your code, that I can help you out. And if you have any more questions during the week where you try to make that code, so you can try to send me some snippets of the code and I can try to help. So anyways, if you run today's template, so in beginning nothing shows up because I changed some of the major things. So I removed position 2D and I removed direction, because I wanted to replace it by this numpy alternative in JavaScript called, it was called Numjs. So the library is called Numjs. But the way how you then operate with it, it's very similar to numpy. So that's why I really like it, and I wanted to show you and trying to use this in this game as well. So basically, let's say we have, so you don't need to write it, just look how it looks similar to what we have in numpy. So nj array, so in numpy that would be np array, right? So 1, 2, 3, so now we have a listed as array. So if I write a to string, for example, then I get array like that. If I write it to list, I get it like that. So it's fine. So similar, like it would be just a JavaScript array or JavaScript list, but then interesting things start to happen. So if I'm adding, for example, add, so I can add to all elements at once, like 1, for example, and then I would write it to list, and you see that all elements are added by 1. Very, very useful thing. So this is mathematical library. You can imagine we can do all sorts of things like dot products, like adding, reshaping and stuff like that. So there's also things like nj arrange, range, and you can, for example, generate 10 numbers in a list like that, exactly like in numpy. Then you can, for example, add two vectors or multiply two vectors directly to each other. For example, if we have B here, and this B will be nj array, this will be 4, 5, 6, like that. And then what we can do is, for example, A, or we could even write it like, yeah, A multiply by B to a list. So we are multiplying together this vector of 2, 3, 4, I think. Oh no, we are multiplying the, the 1, 2, 3, because, so if I write here to list what was in those variables, so this is this, and this is this. So it's when you do any multiplication or something like that, it does not modify the vector itself, but it returns the vector. So if I would like to store the result of this in some kind of C vector, so then the C to list will contain the output. So it's not an inline functions. They are always returning something. So you see, this is very similar to the numpy. And that's why it's very convenient to use it in games and some kind of mathematical procedures. So let's go back to the code and try to take an advantage of this library and also implement the Singleton and a few other things. So I added also an explosion element here. I will zoom in. Oh, sorry, zoom in. So we zoom in, there is the element counter, right? So sorry, so this is that part. So you see that I added the position, and here when I set position, I check if the element at position 0, a position 0 that is X, a position 1 that is Y, if that is so for example, if the, so what it means is that if position X is lower than 0, then I set position X to 0. So the first parameter is the position and second parameter is the value. So that's the way how you set it using this library. So that part. Then if we go down to the line number 162, so there is a check collision part, which we will implement a little bit later. And then on the line 187 or so. So there we have the update function. So previously update function, remember, was done by X and Y separately. Now if we are using mathematical library, we can do this at once for both axes. So here we have the directions for all of the up, down, left, right. You can see that they are nj arrays. So, and now here to create the position that we will move the elements. So this could be then written as this position add. So let me think. So except we need also to set it as that. So position add. So we will add something to existing position, and this something will be this direction, and multiply. So for numpy, I realize it's much nicer that you can use the common mathematical notion, right? So they have overridden the operators, but for the JavaScript, it's not so easy. So this speed multiplied by delta time. Oh yeah, you're right. In my template, unfortunately, I wrote it a little bit wrong here. Yeah, sorry, you're right. The correct way would be here to use the hashtags for the private variables. I accidentally used the underscores because from like the same way as it was in the Python. Sorry for that. That's a very good point. Thank you for letting me know. So actually should use hashtag direction, but anyways. So for now, let's stick with what we have here. Sorry, you're absolutely right that that it should use the private variables in the JavaScript style. So sorry for that. Okay, so I'm dropping this on the slide number 5. Really good that you're following the code and starting to understand how the code looks like in JavaScript. So I'm dropping this to the Jamboard slide number 5. So this line is basically mathematical operation where I multiply the speed times delta to the direction vector, and then I directly add that direction vector to our position vector. So like the same way as we can do in numpy and mathematical libraries, but just using the JavaScript. So if I go back here, you definitely need to play around with NJ library. So as I showed you before on those examples, it's very useful to play around with it and start to understand what you can do with it. Yeah, maybe I should drop some examples in the Jamboard as well. Anyway, so that part. Then let's see where else we have some to do. So there in the so we have to do in game state. So the game state now is not a singleton. So we need to convert this class to the singleton, so that also the game would work properly. Okay. So the way how to do this is following. So first we define some kind of static internal private variable which will not be accessible from outside of the role. So instance equals null, for example, or false, it doesn't matter really. Then we should check if game state hashtag instance exists. So if it already has been initialized, then we do not allow to initialize this instance twice. That's why it's singleton, right? So we can throw the exception, so new error. So in JavaScript you write it like this, and this error means that there will be written that singleton cannot be initialized twice, right? So we will add this error. And then, of course, we need to change this part where we don't create a new instance every time. We only create a new instance when it's necessary. So the way how we can write it then is maybe, let's see. So if game state hashtag instance, because this is, so we can access static variables, as we can access private variables from inside this class. We cannot access the hashtag private variables outside of this class. Okay, sorry, I don't know what I did here. Okay, good. So this will be, if this is false, or basically if this is equals to null, right? Then in that case, we will create a new instance. So this will be game state instance. Okay, why I cannot copy it for some reason. No, new game state. Like that. And then return the game state. Like that. So now, this is a kind of proper singleton now. Also, you see that I added JScene to the singleton, so that means that now we don't need to pass JScene to the draw function. We can just access it through the game instance game.instance to JScene. So this is kind of like the set of game state, which is globally available for all of the parts of the game. At the same time, we can yeah, we can later implement, for example, saving of the game. Like we can implement the serialization of the state. So here also probably we should have the score. So score 0. Now let me see if it works now. Yeah, so seems to be working now. So if you get it so far, let me know in the chat, and then we will do the collision part using this approach, using the Numjs library. So this is the Singleton again. Okay. So let me ask in the chat. So is code working so far? Okay, I see 1+, I guess. So far. So if it's working so far, okay, I see 2 pluses. Then you get it running like this, where you actually can move it around and shoot rockets, you know. Of course, I don't have yet implemented the things that I asked you to do for the homework. But anyways, you will have another attempt to try to implement them a little bit better using the comments that I gave you in the beginning of the session. Okay, so I see 2 people online and 2 pluses. Hopefully, the Christiana will also do something later. Okay, I will see. Christiana is also here. So that's excellent. That is perfect. So, okay, great. So then let's go to the collision part. So I wanted to make the collisions the similar way as we did in Python. Of course, you could do it like another way, as we saw on today in Rocket's code, where he just like I think it was Rocket's code where he used just in the rocket collisions, you know, because the rocket collision is also a valid way, because normally most elements will not collide with each other except rockets. So that is really also not totally bad idea to do that. So let's see. So we have is collision there, and we can now use the NJ library again to make it a lot simpler, so without many lines of code. So the way how we can do this is then the if. So let's write it in with the more variables. So so this will be let. Let's write it like this. Let position round will be then the nj round. So this will round the vector. So this position. In NJ library, you have all sorts of useful functions you can use for mathematical operations. So other, and there will be the other, or sorry, so this is this position, and then other position, right? So this is great. We have to do those 2 positions here. Then if these equal, and we don't need to check both dimensions anymore because we have mathematical operation equal there. So then this will be pos round equal. And these function names, they are not automatically given for you in the WebStorm. You need to find them inside the GitHub where there is this what was the name again? Numjs. So basically, if you want to find the functions for this library which are useful to use, then look for functions in Numjs GitHub repo. So it's called Numjs. So basically, this NJ syntax. So, anyways, so this is if this is equal, then is collision true, right? So this is good. So then the collision is true. Hopefully there is no bugs. I'm not 100% sure, but let's see. So I'm dropping this to the Jamboard. So this was going to the Jamboard, slide number 6. Oh, that was Evert's code, sorry, where there was the checking only in Rockets, so that's great. But right, the Rockets code was not that optimal. So anyways, that's fine. So that's good, that's good. So the collision part of the code is added to the Jamboard. Really hope that you can catch up with this, and then we will move on to the actually checking of the collisions. And I want to do this again the same way as we did it before, using the basically using the way of the approach as it was in the Python. Of course, if you're following this tutorial and not knowing anything about the Python, I hope that that's also useful to see the ways how to do this. Okay, hope that collision code is okay. So now if we move down to the here in the main game loop, I added to do here, to add the collisions, right? So that is the main game loop after. So this is after the draw. Let me think, is it a good idea to add it after the draw? So update, so it will update. So it's not a good idea. The better idea would be added before the draw. So if there is a collision, I don't want to see it that it is in the, like it first collides and then afterwards it disappears. So let's write it here. So then for, now by the way, we also in the, so there's let is collision. I'm trying to write it in the same way as it was in the Python. So for let I equals 0 equals lower than elements length. This was the same code that I think most of you got it right. So the Everts, Rockets, and Christiana also write this correctly. Then the next part is where you need to make the code optimal so that it's not wasting resources without reason. So there is a j here, and then here there is I plus 1, and then j. So they are not crossing actually. So they are not repeating the same combination twice. That's quite important stuff here. So anyways, so that part, then checking the elements, right? So maybe it would be easier to write about the elements, to write elements in a little bit different manner. Let me think. Yeah, so let's write it, so this will be element A. So this will be element, let's call it element I. Elements I, like that. By the way, notice that elements are the same pointer to same array that is stored in game instance elements. So again, this line of code must be understood very carefully. So the line 313, very important line. So let me zoom in. So that line, basically, do not copy value. Remember, we talked so many times about the pointers. It copies actually the pointer to memory location where there is the element stored. And that's why I can operate with elements here and change them directly in this pointer of the array, and it will automatically also change inside that game instance elements. This will not be true if we do this same thing with score. For example, if I would write here let score game, so this is again about the pointers. So this is a complex types, and they are not something that you can copy easily. So if I write here score and then I set score to 7 here, then score here in this variable will be different than in this variable. But if I change something in elements here, this will be the same also in the game instance elements, because the elements is complex data type array, but the score is just an integer, just a number which can be copied easily. So that's something just to remember about the pointers, and I'd really hope that by the end of all of our tutorials, you will understand pointers very well, and you will not have no problems about like you will not write some kind of strange code. So element II, element j here. That's great. So then we can use the syntax that I just showed today with the with the Christianus code. So here will be then element I, instance of. So if this object or the instance is basically rocket, and at the same time, so maybe we should add around here the brackets. So if this why would it get stuck in the oh, sorry, you're right, I didn't route it correctly. Yeah, so thank you for in the chat. So there's e+1, crazy stuff. Rohit helped me twice today already with some small bugs here. So yeah, this line is correct. It should be like this. Thank you for understanding the code and following it. So basically, if we want to not repeat the check for the elements, then we should start every j starting from I+1 and then go j up till elements. I accidentally wrote it in that way because in Python you write it a little bit different. But yeah, you're absolutely right that this should be like that, and this should be like that. So it was the same in your implementation. If it wasn't like that, so that would be great. Let me check. Maybe I accidentally said something wrong. Yeah, it seems that you... Oh, but was it your implementation? Whose implementation was it? It's I+1. Okay, great. I think you had it the same. And even, yeah. So you had it the same, so that's great. Rohit did good, I think. So yeah, you're right. I missed that part twice already. So let me add here cookie. So Rohit helped quite a few times today, and also his code was doing the right thing already, but I kind of did not notice that small part there. Anyway, so that's great. So if this is a rocket and if the second element is not a rocket, so this will be the check just for the rockets, definitely this would be smarter probably to move to a rockets code as Everts did, so that was a good call there. But in this case, let's write it the same way as it was in the Python. So element j is just the way that we can explore more of these functions. So rocket, so this means this is not the rocket, the other one. So either this is true, Again, let's try to write it in some reasonable manner. Let me see, how could we make it more reasonable? Okay, let's so this will not be then optimal code, but it will be more readable. So let's make it more readable, not optimal. So is collision, there will be true, but we will also need to check then a few things. So is collision true here, and then let's add up here the collision check. So if element I check collision with the other element j, then add the brackets around this part like that. So this will be one part. Then let's add here, or else if this guy basically is the same code as this, only we changed I and j places. So this means either one of them are rocket, then we're doing something. So this part of the code is definitely not optimal. If this would be a production game, it would not be acceptable. It's just trying to make the code a little bit more simpler. So then maybe you have better ideas how to write it without extensive conditions. So if this is collision true, then in this case we need to first of all break out of this loop, I guess. Yeah, so let's break out. Also, let's break out here if is collision, then let's break out of this one as well. And finally, finally we should add some kind of, so let's see, so elements, we will remove both elements. So element j removed, there is a function remove, and the element I also should be removed. Then I hope this is enough to make this work. Let me see if I don't have any other mistakes here. Oh no. So if I shoot out immediately, I get removed because it hits the player itself. So let me see. Okay, anyways, I will add this code to the Jamboard, and we will fix the problem with the player removal of shooting the rocket. So I will add this to the Jamboard. I just want today also to make the code for the explosion a little bit, and next time we will work with the observer pattern and implement the movement of aliens. So let's see. So to fix the problem with the with missing, so that when we shoot out fire rocket, then bad things happen, is following. So there is the round position, right? What we could do probably is, let's see, rocket position set. So let's set the y-axis to, so this will be the kind of position from that part, -1. Or maybe we could set it in, okay, let's see. Position minus, I think there was that kind of function there. Let me check Numjs library, scientific computing library for JavaScript. Sounds about right. Subtract. Sorry, there is a subtract. Okay. So subtract nj array from 0 here, then 1, like that. And then we need to set it inside the rocket position, hopefully like that. And I also forgot the colons at the end. It should be added there. So, no, yeah, nice. So now it's working. Yeah. Okay, so now it's much better. Okay, so I will show you how it looks like. Looks like as a result. So that now if you add that part, so the rocket starts flying immediately some distance apart from the player, and now I'm able to shoot it like that. So that works fine. I'm now dropping this line also to the Jamboard. Slide number 7. I think it will be slide number 7. Okay, I accidentally dropped the previous code in, no, I don't know, in which part did I drop it? Yeah, I accidentally dropped the check collision code in the slide number 4, so no worries, I will move it to the end so everything would be more uniform. So now I'm putting in the Jamboard slide number 7 the changes for the player. Now copying. By the way, if you have any questions regarding what we're doing now, then please don't be shy and ask them. Like it's better to try to understand it together. If you just copy that part of the code which seems not understandable, I can try to explain if necessary. So anyways, I added that to also the Jamboard. Now let's make only the explosion part, and again I want to make explosion part similar to what we had in the Python. So the explosion part in the Python was using the same elements basically as we had before. So I mean we're using the update function, so we don't need anything else there. So let's say update, and it automatically generates all of this code in the WebStorm. So it's overriding the initial class, right, using the inheritance. Okay, so that's great. So now I will make properly the private member variable that I did wrong last time. So life will be the how long this should be visible, like that, and then we will remove the life step by step here. So it will be then this life minus delta time. And as soon as the life is ended, so if this life is lower or equal than 0, then in this case we call this remove. So I think code for explosion very simple, right? So I'm dropping the code for explosion also to the Jamboard. So, and at the end, you need to add those explosions then. So where was it? Here. So there is a is collision. So let's add the explosion at this position. So how was it in the Python? How did we add it in the Python? Just a position of one of those elements. And we could round it probably. Okay, so let's try it. So, so there will be the elements. Again, the pointer, the same pointer which is inside the game state. Elements push new explosion. And now there will be the NJ stuff. We cannot just, so there is again very interesting stuff. If I will just write it L like that, it will send the pointer to that position directly inside that one, which is not what we want actually. So one way would be to use this round function, which will create also the copy of that and will round the position. So hopefully this will work better. I'm not really sure. Maybe without rounding, just copying would be better. If you want to copy, then you would write array here, like that. Or maybe I will check if there is a clone function, maybe. Clone. yeah, there is a clone. So the other way, you could just write dot clone. Oh, sorry, what's happening here? Dot clone. So you can write it like that as well. Because again, this is then it will be just a pointer, and the pointer is not what we want here. So, okay, so that part is fine. Okay, so now it seems really nicely working. We'll show you how it looks like. So I will drop this part in the Jamboard. Okay, maybe I should the whole part. So this is creating the explosions as well, which are appearing and then disappearing by the limited amount of time. And by the way, now for the next time, please then implement correctly, most of you. I think Rohit was the only one who implemented partially, so like almost correctly all of these parts. And I mean, the one thing is please implement the ability to not shoot more often than once in a second, not without using the set timeout or something like that, using actually proper logic. So let me now go to the code here. And you see, if I'm like trying to shoot rockets now, they are generating also these nice explosions, and then they are disappearing. Everything is working really nicely. And now it's working using this mathematical library, not actually the not the just self-defined vectors. So yeah, so I will think of some tasks for the next time. One task could be I will add in maybe the we'll improve the template, or maybe you can do it, so that the idea that aliens, even if they are not moving now, maybe they could shoot back to you, you know, like with some random intervals, just shooting rockets downward direction to you. So that would be nice addition. I will think maybe some other tasks, and next time basically what we will do is we'll generally try to finish the game, and afterwards we will start working also a little bit on server side. So we will try to send the kind of high scores for this game to the server, store them in some database, and then basically that will be really funny if we can all of us play with the same database and store the scores at the same database from each of our different implementations of the game. And afterwards, the next step in our progression will be that we will try to implement the same thing in React Native for the mobile app. So you will have probably gone through different stages of kind of knowledge necessary for being basically full stack developer. So that's it for today. I will prepare the homework for next time, and yeah, try to start at the time for next time. Sorry for a little bit of delay. Okay, so that's it for today. Bye bye.